Morning, sir. My name is K. Manoj Kumar. I am from I section, and my roll number is 24011, capital A0514. In this section, I am going to explain about my topic, first order RL circuits, which is from BEE Basic Electrical Engineering. First order RL circuits, inductor resistor circuits, are fundamental building blocks in electrical and electronic systems, playing a crucial role in various applications such as power supplies, motor control, and signal processors. These circuits exhibit unique transient and steady-state behaviors that are essential to understand for effective circuit design and analysis. RL and RC circuits. Let us start from RC circuits. RC circuits are categorized by a capacitor that stores and releases energy, leading to an exponential charging and discharging behavior. These circuits are widely used in timing, filtering, and coupling applications. Let us start from RL circuits. RL circuits, on the other hand, are categorized by an inductor that stores and releases energy in the form of magnetic field. These circuits exhibit a different transition response compared to RC circuits and are commonly used in power supply, monitor control, motor control, and signal filtering applications. Charging and discharging process. So there are three types: charging, steady state, and discharging. In charging, when a voltage source is applied to an RL circuit, the current increases exponentially as the inductor stores energy in the form of magnetic field. This charging process is governed by the time constant of an circuit, which determines the rate of change in the current. Steady state. After the transient charging or discharging process, the circuit reaches a steady state condition where the current and voltage level remain constant, determined by the resistance and the applied voltage. Discharging. When the voltage source is removed, the inductor releases its stored energy caused by the current to decrease exponentially, which decreases exponentially. The discharging process is determined by the time constant of the circuit, by the direction of current flow is reversed. Time constant and its significant. Time constant. The time constant of an RL circuit is defined as the ratio of inductance L and the resistance R, and it determines the rate of change in the current during the charging and discharging process. Significance. The time constant is crucial in understanding the transient behavior of RL circuits. It governs the time it takes for the current to reach a specific percentage of its final value, which is essential for designing circuits with desired response times such as motors, control, and signal filtering applications. Relationship and inductance and resistance. A higher inductance L or the lower resistance R results in a larger time constant, leading to a slower response time. Conversely, a lower inductance or higher resistance results in a smaller time constant and faster response time. Differential equation for RL circuits. Differential equation. So there are three. three main types: differential equation, solving equation, and the importance in analysis. The behavior of RL circuits can be described for the first order linear differential equation, which relates the current, which relates about the current, voltage, resistance, and inductance of the circuit. The equation is essential for analyzing the transient and steady state responses of RL circuits. Solving the equation by the RL circuits, we can solve the many types of equations, such as, let us get into the definition. The differential equation can be solved using various mathematical techniques. So it can be solved during various techniques such as method of integrating factors or Laplace for transformers to obtain the time domain and frequency domain expressions for the current and voltage in the circuit. Importance in analysis. The solution of the differential equation provides a complete understanding of the circuit's behavior, enabling engineers to predict and analyze the response of RL circuits under the different input conditions and design circuits with the desired characters. Transient and steady state response. Let us go for the transient response. The transient response of the RL circuit refers to the temporary exponential change. It refers to the temporary exponential change in the circuit in current or voltage that occurs application, immediately after the application or removal of the voltage source. This response is determined by the time constant of the circuit and the initial conditions. Steady state response. The steady state response refers to the final constant value that the current or voltage in RL circuit reaches up after the transient response has subsided. The steady state value is determined by the resistance, inductance, and the applied voltage. Significance. Understanding the transient and steady state responses of RL circuits is crucial for designing and analyzing various applications such as motor control systems, such as power supplies, motor control systems, and conditioning circuits, where the dynamic and steady state behavior of the circuit must be considered. Applications of first-order RL circuits. Power supplies. RL circuits are used in there are four types: power supplies, motor control, signal processing, sensor interfaces. There are four types of applications in which power supplies. RL circuits are used in power supply designs to smooth out ripple and provide voltage regulation, and the inductor helps to maintain a steady current flow. Motor control. RL circuits are employed in motor control systems, control the speed and torque of electric motors, as the inductor can regulate the current flow and limit the rate of change. Signal processing. RL circuits are used in signal conditioning and filtering applications, where the inductor's ability to block high frequency signals is relegated to remove unwanted noise or interference. Sensors interfaces. RL circuits can be used to interface sensors such as current sensors or Hall effect sensors by providing the necessary impedance matching and signal conditioning. Here are the key takeaways. So here are some important points which are taken from the topic from first order RL circuits, introduction to RL circuits and RC circuits, charging and discharging process and steady state conditioning, time constant and significance, and the relationship between inductance and resistance, which are definitions. Differential equation of RL circuits, which is very useful in solving many of the problems in mathematical techniques, and the importance in analysis, transient and steady state response. And we can see significance of transient and steady state response. Understanding the transient and steady state response of RL circuits is crucial for designing and analyzing various applications such as power supplies, monitor control system, and signal conditioning circuits, where the dynamic and steady state behavior of the circuit must be considered, and the applications of first order RL circuits, such as power supplies, motor control, signal processors, sensor interfaces. Let's go into the key takeaways. Transient and steady state behavior. RL circuits exhibit unique transient and steady state responses, which are determined by the time constant and the applied voltage. Time constant. What is meant by time constant? The time constant T is equals to L by R of an RL circuit governs the rate of change in current during charging and discharging. It is a crucial parameter in circuit design and analysis, which is very useful for the circuit design and analysis process. Differential equation. The behavior of RL circuit can be described by a first order linear differential equation, which is essential for understanding and predicting the circuit response, which is very essential for understanding and circuit response. Applications. RL circuits can find applications in power supplies, motor control, signal processing, and sensor interfaces where their unique characteristics are privileged to achieve desired circuit performance. These points are have been read already, so these are the key takeaways for the points. And lastly, I conclude that first order RL circuits are fundamental building blocks in electrical and electronic systems, exhibiting complex transient and steady state behaviors that are essential to understand the effective circuit design and analysis. As we know that by mastering the concepts of this constant differential equation and the various applications of RL circuits, engineers can design and optimize these types of circuits for a wide range of control, power, control, and signal processing applications. So these are the many important topics about first order RL circuits. Charging, steady state condition, charge discharging, time constant and its significance, differential equation for RL circuits, such as importance in analysis, solving an equation, differential equation, transient and steady state responses, as and here we can even learn the significance of it. Applications of first order RL circuits are of four types like power supplies, motor control, signal process, and sensor interfaces. Key takeaways are the points which I have read already. And thank you.